Welcome back to Daily AI Brief, your go-to source for the latest developments in artificial intelligence. Today, we dive into cutting-edge AI models, explore ethical dilemmas, and discover how AI is reshaping industries from fashion to space exploration. Stay with us as we unpack these complex topics with insights tailored for the engineering minds among us. IBM has set a new benchmark in speech recognition technology with the release of its Granite Speech 4.1 models. These models, designed for automatic speech recognition, ASR, bring new efficiencies and capabilities to multilingual environments. The Granite 4.1 models feature dual-head CTC encoders, enabling them to effectively handle ASR tasks across languages like English, French, German, Spanish, Portuguese, and Japanese. Each encoder can generate graphemic and byte pair encoding, BPE, outputs, granting significant flexibility. This architecture supports both fine-grained detail for languages with more phonetic intricacy and more compact representation for languages with extensive vocabularies. Additionally, some variants like the Granite Speech 4.1 2B NAR utilize non-autoregressive architectures, providing faster processing and reduced latency. This is particularly beneficial in scenarios where real-time processing is crucial, such as live broadcasting or interactive voice response systems. These models have been trained on a staggering 174,000 hours of audio data, drawn from both public corpora and synthetic datasets. This immense dataset provides a comprehensive basis for language modeling, enabling the models to capture a wide variety of accents, dialects, and speaking styles. While the exact transcription accuracy figures aren't disclosed, the use of such extensive data suggests notable improvements. Keyword biasing further enhances recognition of complex terms, allowing enterprises to better handle technical jargon, proper nouns, and industry-specific acronyms, which are often challenging for traditional models. However, deploying these models isn't without challenges. The models might demand substantial computing resources, and customization can be complex, especially in varied enterprise settings. Integration into existing systems requires careful consideration of current infrastructure capabilities. Performance can also fluctuate with different languages or dialects, potentially varying by as much as 15 to 20% in accuracy, depending on the fit between the model's training data and the specific linguistic characteristics of the target speech. For those interested in exploring these capabilities, the models are available on platforms like Hugging Face, providing easy access for developers and researchers. IBM also provides detailed documentation and demo code to facilitate integration and experimentation. These resources allow potential users to trial the models in sandbox environments before full deployment, ensuring compatibility with existing workflows and applications. The release of IBM's Granite 4.1 models highlights the potential for enhanced transcription and translation services in multinational enterprises, offering both performance and adaptability. As businesses expand their global footprints, tools like Granite 4.1 could be instrumental in bridging communication gaps, fostering more inclusive and effective global operations. Imagine transforming your development workflow by integrating a team of coding agents directly into your GitHub repository. That's what Squad offers with its innovative multi-agent orchestration platform, a game-changing approach designed to boost productivity and efficiency for developers. Squad integrates AI agents functioning in specific roles such as lead developers, front-end developers, back-end developers, and test engineers. These agents aim to elevate collaborative coding environments by executing tasks like design decisions, implementation, testing, and code reviews using natural language inputs from developers. By facilitating such automated processes, Squad addresses the growing complexity in software development, eliminating the need for elaborate orchestration layers typically required for complex projects. Technical integration and functionality. As an open-source tool available on GitHub, Squad is seamlessly integrated into existing development workflows. After installation via the Squad CLI, developers can configure the agents within the project repository through various command inputs. This setup is designed to be repository native, meaning agents can persist across different coding sessions, continuously learning and adapting from the codebase. This capability allows these agents to make more informed decisions over time, thereby improving efficiency and potentially shortening development cycles. Practical steps and evaluation. To witness Squad's potential, developers are encouraged to visit the Squad GitHub repom, Bradygester Squad Source OpenA for detailed installation instructions. By setting up Squad in a sample project, users can directly assess its effectiveness at improving code management and automating redundant tasks. Developers can also follow GitHub pilot documentation, docs.github.com/tutorials, rollout scale, enable developers, integrate AI agents, Source OpenAI, to successfully integrate AI agents into their environments. Addressing trade-offs and limits. While Squad provides numerous potential benefits, it does bring certain trade-offs and limitations. The effectiveness of its AI agents can vary depending on the specific nature of the coding tasks and environments they operate within. Transitioning to workflows that rely on AI orchestration might necessitate significant adjustments, potentially raising challenges in maintaining code consistency if the agents do not communicate effectively. Additionally, while long-term reliance on AI might alleviate routine burdens, there's a speculative risk of skill degradation among developers who might become over-reliant on these tools. Business and individual adoption rates also remain uncertain, as the technology seeks to demonstrate its full long-term effectiveness across diverse coding settings. Looking ahead, Squad's vision positions AI as a complement to human developers rather than a replacement. This collaborative approach could significantly reshape the software development landscape, offering productivity enhancements while still allowing developers to focus on complex and creative problem-solving tasks. As AI continues to evolve, Squad represents a leap towards more sophisticated, autonomous systems in coding roles, possibly inspiring future advancements in AI-assisted development processes. AI outfit generators are transforming the fashion e-commerce landscape by eliminating the traditional reliance on physical photo shoots. This shift is driven by advanced technologies like those from Vue.ai and ZMO.ai, which are not only setting new standards in cost efficiency, but also revolutionizing the online shopping experience. The core of these technologies lies in systems such as TrendGen, which utilize multi-layer neural networks for sophisticated image generation. These AI-driven tools convert basic raw images into polished and detailed visual displays, aligning with current fashion trends. The integration of generative AI into e-commerce platforms streamlines processes, dramatically reducing the time to market for new fashion lines. It allows retailers to deliver personalized outfit recommendations directly to consumers, thus enhancing engagement. The growth in user engagement with these AI tools is highlighted by a staggering 700% surge in shopping-related queries between 2024 and 2025. This dramatic increase reflects a significant consumer shift towards embracing technology in shopping habits. Platforms like Shopify Plus have reported improved conversion rates when utilizing AI-generated images, though user acceptance can vary. Some consumers express concerns over the perceived authenticity of AI-generated imagery, which can affect their buying decisions. For businesses exploring these innovations, practical steps include reviewing API documentation for tools such as Vue.ai, which offers a pathway to integrating AI image generation capabilities. Additionally, budget-friendly models like ZMO.ai provide smaller retailers with access to sophisticated image generation without heavy investment, available through trial phases for a practical evaluation experience. Despite the efficiency gains, the long-term impact on traditional fashion processes and roles, such as photography and design, is yet to be fully understood. The industry's evolution may lead to a reassessment of these roles as companies align their brand identities with the capabilities of these AI systems, meeting evolving customer expectations. Adopting AI outfit generation can significantly cut overhead costs and accelerate the pace of innovation for e-commerce platforms. As more brands experiment with and adopt these technologies, the competitive landscape of online fashion retail is likely to intensify. This move not only speaks to a technological trend, but also suggests a broader cultural shift in how apparel is presented and marketed to consumers in the digital age. ComfyUI is revolutionizing the way creative professionals architect and scale AI-assisted workflows. This open-source tool, first released in January 2023, offers a user-friendly, node-based graphical interface that greatly simplifies the creation and execution of complex generative AI tasks. The platform's architecture is built to support local execution on NVIDIA GPUs, significantly enhancing both privacy and performance. Particularly valuable for industries like gaming and video production, this feature allows for intensive computational tasks without the need for cloud resources, thereby decreasing dependency on external servers and reducing associated costs. With local execution, users can fully leverage the power of NVIDIA RTX Video Super Resolution, allowing for tasks such as 4K upscaling, which is crucial for high-definition content creation. ComfyUI integrates seamlessly with leading generative AI models, including Stable Diffusion and Flux, and offers real-time previews, fostering a dynamic and interactive development environment. Its strength lies in the ability to construct complex workflows on a visual canvas, where nodes represent different stages and operations. This interface not only simplifies the process, but also offers reusability of workflows, enabling projects to be managed more efficiently and innovatively. The addition of live node connections further augments its applicability in rapid development cycles. Financially, ComfyUI stands robust with its recent $30 million funding round, pushing its valuation to a remarkable $500 million. This financial backing reflects confidence in its potential, as evidenced by its user base surpassing 4 million and daily downloads topping 150,000. Such numbers underscore not only its growing popularity, but also its impact in the generative AI space. However, like any open-source initiative, ComfyUI faces challenges. The effectiveness of local execution is heavily reliant on the user's hardware capabilities, particularly the efficiency of NVIDIA GPUs. The integration with NVIDIA software can result in varying performance outcomes based on different system setups. Furthermore, while the platform fosters innovation through community contributions, the quality and consistency of community support can fluctuate, potentially impacting onboarding and user experience. For those interested in diving deeper, ComfyUI provides extensive documentation and resources on their official website /comfy.org/UTM/source-openA, and the NVIDIA developer blog offers valuable tutorials and insights. The utpsno.youtube.com/watch VAQ1T VU source OpenAI presents a concise visual introduction to its capabilities. The continued growth and potential of ComfyUI suggest a shift towards democratizing AI tools in creative production. By enabling powerful, customizable workflows that operate efficiently on local hardware, it promises to redefine digital content production, enhancing creative freedom and reducing external dependencies. In the face of rising environmental concerns, nearly 120 organizations have urged Congress to reconsider fast-tracking AI data centers due to their significant carbon footprint. The rapid expansion of such centers threatens to outpace sustainable regulations, posing ecological risks. These new data facilities, requiring extensive energy, are predicted to emit greenhouse gases exceeding 129 million tons annually, surpassing the emissions of countries like Morocco. The scale of this problem is immense, given that data centers accounted for over 4% of the total U.S. electricity consumption and emitted over 105 million tons of CO2 in 2023 alone. Major tech players, including OpenAI and Meta, plan to integrate dedicated natural gas power sources to minimize reliance on the U.S. power grid. However, while aiming to ensure operational stability, this approach potentially exacerbates environmental degradation, emphasizing the need for sustainable energy solutions. Legislative responses have been swift, with figures like Senator Bernie Sanders and Representative Alexandria Ocasio-Cortez spearheading the Artificial Intelligence Data Center Moratorium Act. This proposed legislation aims to impose a temporary halt on new data center construction until robust environmental safeguards and community consent mechanisms are established. The act underscores a growing recognition of the need for stringent regulatory frameworks that balance technological advancement with ecological preservation. On the financial front, the impact of environmental activism is palpable. In Q2 2025, community opposition led to the blockage or delay of 20 projects worth $96 billion, reflecting a broader public demand for environmentally conscious development. As public awareness around climate issues grows, organizations find themselves at the convergence of environmental stewardship and technological necessities. For tech developers and companies, moving forward involves practical steps like integrating renewable energy sources and adopting energy-efficient technologies. These measures not only aim to reduce dependency on fossil fuels, but also help lessen carbon footprints. Moreover, engaging in transparent community consultations can align data center projects more closely with local sustainability goals, potentially easing public resistance and fostering community trust. The ongoing tension between the rapid growth of AI infrastructure and environmental responsibilities highlights a critical challenge for policymakers and the tech industry alike. Navigating these issues will require innovative solutions, regulatory foresight, and a steadfast commitment to sustainable development. As the debate evolves, the impact of these data centers on both the environment and technological advancement will remain a pivotal issue shaping future legislative and industry practices. NASA's Artemis II mission, powered by advanced AI systems, marks a pivotal return to crewed lunar missions, showcasing how AI enhances space exploration in ways previously considered unattainable. At the heart of this mission is NEC's System Invariant Analysis Technology, SIAT, which serves as a watchdog for the spacecraft's system health by monitoring for anomalies and ensuring operational integrity. SIAT-T's integration not only enhances real-time decision-making abilities, but also allows for the simulation of potential challenges astronauts may face, thereby significantly increasing mission safety and reliability. This technology is particularly critical as it learns the normal operational behaviors of spacecraft to detect deviations swiftly. It achieves this by processing vast amounts of sensor data in real time, a necessity due to the demanding and unforgiving conditions of outer space, where reliability is absolutely non-negotiable. SIAT-T can detect deviations down to a granular level, thus averting systems failure before it occurs, demonstrating a reduction in potential operational failures. In practical terms, deploying AI in such a manner provides substantial cost-effectiveness by introducing predictive maintenance features, optimizing mission resources, and prolonging the operational life of spacecraft components. This efficiency not only offsets significant operational costs, but also enhances mission safety. The AI systems contribute to a reduction in the risk of failure rates by preemptively flagging potential issues. However, while operational efficiency has reached new heights, long-term dependence on AI introduces certain risks. Unforeseen scenarios could challenge current AI capabilities, and potential system errors could pose significant threats if not accounted for properly. The AI's learning and adaptation are continuously refined to ensure applicability under various scenarios. But limitations still exist, since the detailed extent of AI's contributions is proprietary and not fully public. Additionally, the long-term reliability of SIAT and similar technologies in vast, prolonged space missions is still under evaluation. The successful implementation of AI in launching Artemis II sets the stage for its broader application in aerospace. With AI systems facilitating real-time monitoring and diagnostics, subsequent missions could potentially explore deeper into space, reaching destinations such as Mars. The lessons learned from Artemis II will inform future collaborations between aerospace and technology companies, potentially leading to the development of more autonomous spacecraft that are capable of conducting complex operations without constant human oversight. Stakeholders and enthusiasts can further explore NEC's blog for a detailed discussion of their AI contributions, or consult NASA's Artemis II mission overview for an official account of the mission's intricate workings and AI's role in it. These resources offer detailed insights into how advancements in AI are driving the future of space exploration. Ultimately, AI's role in Artemis II exemplifies the significant strides made toward more autonomous and secure space missions, potentially forming the foundation for deeper explorations. As NASA and other space agencies look to push the boundaries of human presence in space, AI will be pivotal in advancing aerospace technology, ensuring safety and enhancing the success of future explorations. Google Research has developed Empirical Research Assistance, ERA, a groundbreaking AI tool poised to transform public health forecasting. By leveraging advanced computational modeling, tailored specifically for epidemiology, ERA enhances the accuracy of epidemic predictions for diseases such as COVID-19, influenza, and respiratory syncytial virus, RSV. Announced on April 29, 2026, ERA stands out by significantly improving the timeliness and reliability of health forecasts, which are crucial for preemptive public health measures and effective crisis management. ERA's core strength lies in its cutting-edge machine learning algorithms, which process vast datasets to generate data-driven forecasts. These algorithms are integrated with real-time monitoring systems, allowing for a dynamic interaction with existing public health databases. For instance, ERA actively contributes to the CDC's Flu Forecast Challenge, submitting weekly predictions that regularly rank near the top of performance leaderboards. This integration not only showcases ERA's capabilities, but also underscores its potential to support health authorities in decision-making processes. The design of ERA's APIs facilitates seamless access for public health officials and researchers, democratizing the use of sophisticated computational models in epidemiology. This democratization is crucial as it enables broader participation in public health forecasting, particularly benefiting smaller organizations that may lack the resources to develop such technology independently. However, the ongoing challenge remains, ensuring these organizations have sufficient resources and expertise to effectively deploy and interpret ERA's outputs. Despite its promising performance, some limitations accompany ERA's deployment. One primary concern is the lack of detailed comparative performance metrics, which could obscure its advantages over competing models. Furthermore, the scalability of ERA in diverse epidemiological contexts remains under evaluation, raising questions about its long-term effectiveness. Additionally, there is a risk of over-reliance on AI for critical public health decisions, which necessitates careful consideration of AI ethics and data privacy. For those interested in exploring ERA further, Google Research provides documentation accessible through their official blog posts. These resources offer insights into integrating ERA with existing systems and potential collaboration opportunities via Google Cloud services focused on epidemiology. With ERA, Google exemplifies AI's capacity to significantly improve public health crisis responses. By ensuring that accurate and timely forecasts are available, ERA aids health authorities in allocating resources more effectively, potentially impacting millions of individuals worldwide. ERA's development marks a pivotal point in public health, not only by improving current strategies in epidemic monitoring and forecasting, but also by paving the way for similar innovations across the health technology sector. Its contributions to epidemic management demonstrate the potential benefits of AI in tackling complex health challenges, inspiring further advancements and collaborations within the global health community. On April 28, 2026, Cursor made a significant stride in the world of software development by unveiling a new TypeScript SDK designed specifically for creating AI-driven coding agents. This launch is a pivotal step in revolutionizing how developers integrate AI tools within their workflows, providing them the ability to deploy agents locally, on the cloud, or even through self-hosted solutions. This flexibility is key. It caters to diverse development needs and enables a more dynamic approach to software engineering. The SDK is equipped with cutting-edge features like codebase indexing and semantic search. Codebase indexing enhances performance by systematically organizing and structuring code, making retrieval and execution processes faster and more efficient. Semantic search, on the other hand, allows developers to query codebases using natural language, significantly reducing the effort spent on manual searches and allowing developers to focus on higher-level problem solving. One of the standout characteristics of this SDK is its modular design, providing a unified runtime environment that simplifies the integration of external tools via APIs. This modularity means developers can seamlessly integrate the SDK into existing projects without having to overhaul their entire development infrastructure. The ability to run agents in varied environments, local or cloud, ensures that performance is optimized based on specific project needs, whether they require the speed of local execution or the scalability of cloud operations. Cursor's SDK utilizes the same robust runtime, harness, and models as Cursor's desktop and web apps, ensuring consistency and reliability across different platforms. Furthermore, it supports the latest models, such as Composer 2, providing cutting-edge AI capabilities for coding agents. With advanced task assignment and progress monitoring features, the SDK not only automates repetitive tasks, but also provides a structured approach to workflow management, enhancing developer productivity significantly. Despite its promising prospects, the adoption rate of this technology remains uncertain. Projections place adoption at between 15.85% and 22.60%, reflecting a community still gauging the implications of automation on traditional development roles. Developers may face challenges with integration complexities and variability in agent performance based on deployment mode. For those interested in practical applications, Cursor offers sample projects like a Kanban board and a command line tool available on GitHub. These examples serve as a practical starting point for developers looking to integrate AI agents into their workflows. Installation is straightforward with the command npm install @cursor/SDK, encouraging ease of use and accessibility. By launching this SDK, Cursor is significantly influencing modern software engineering practices. Automating code summarization, bug fixes, and other manual interventions, it promises faster release cycles and increased accuracy. While the long-term impact of widespread AI adoption on developer roles is speculative, the potential for enhanced productivity and efficiency is undeniable, placing Cursor at the forefront of AI-assisted coding innovations. Advancements in AI have ushered in a new era of dynamic context management, moving beyond static prompts to more adaptable frameworks in systems such as Claude Code and Pi. This innovation enhances AI agents' ability to efficiently manage tasks within enterprise applications. Dynamic context strategies leverage memory systems that store and recall information from multiple sessions. These memory systems are technically robust, allowing AI agents to access and manipulate large datasets seamlessly. File-based memory, for example, automates the preservation and compression of data, ensuring quick retrieval and minimal redundancy, which enhances operational efficiency. Subagent frameworks exhibit varying context sharing capabilities. For example, Claude Code supports the inheritance of entire parent message histories, thereby providing subagents with a comprehensive background context that improves decision-making and responsiveness. In contrast, Pi operates in isolation, not inheriting context from parent sessions, which limits its ability to adapt to evolving information. Memory management within these frameworks involves intricate systems that handle operational data intuitively while preventing loss of context and reducing risks such as prompt injections. Active context compression is a new frontier in this domain, achieving a significant 22.7% reduction in token usage without sacrificing accuracy. This reduction minimizes the computational burden and costs, illustrating the potential for efficient resource management characteristic of these systems. However, implementing a dynamic context management system could introduce architectural complexity. Over-reliance on these systems might lead to scenarios where critical historical data isn't preserved adequately, risking data continuity in absence of stringent controls. For those interested in leveraging these capabilities, exploring the agent system's hierarchical memory management offers potential benefits. Alternatively, utilizing LangChain's Deep Agents SDK provides a robust suite of tools for sophisticated context handling, supporting both planning and interaction with file systems. The shift towards dynamic context management presents exciting prospects for AI's role in business processes, potentially leading to smarter and more adaptable AI applications. As AI continues to evolve, businesses stand to benefit from improved responsiveness and reduced manual overhead, allowing for more efficient integration of AI into existing workflows and enhancing complex decision-making processes. That's it for today's episode of Daily AI Brief. We've delved into groundbreaking AI models, considered the ethical ramifications of tech innovations, and explored industry disruptions from space exploration to fashion commerce. As always, thank you for joining us. Keep coding, keep exploring, and we'll see you next time for more insights into the future of AI.